Hello, everyone, and welcome to Building Retrofits for Small and Medium Enterprises, Part 2, Making It Happen, an EnviroCenter presentation. So what is EnviroCenter? EnviroCenter is your friendly neighborhood, local, environmental nonprofit with a mission to provide people, communities, and organizations in Ottawa with practical solutions to lighten their environmental impact in lasting ways. Our work focuses on four main areas. That is green homes, active transportation, including mass transit, green lifestyles, and green businesses. One division of EnviroCenter that deals with energy in buildings is called Energy Services. Within that division, we look at home and multi-unit residential building energy audits. We conduct business energy analysis and audits, and we do business carbon accounting through Carbon 613. We also conduct green audits of various kinds. Carbon 613 is EnviroCenter's program for businesses. It's a membership-based program for Ottawa businesses with access to events, resources, and discounts being provided to members. Members also get comprehensive tools for carbon analysis and target setting, and become part of a local network of businesses committed to climate action. I am Greg Furlong, Senior Energy Analyst with EnviroCenter. I am an energy advisor with Natural Resources Canada, with the Canadian Home Builders Association Net Zero Home Labeling Program, Energy Star, and R2000. I'm also a certified energy manager for the AEE, which is the Association of Energy Engineers. I have done assessments on over 100 multi-unit residential buildings, plus about a dozen commercial audits, mostly on worship spaces here in Ottawa. I've also conducted energy audits on about 700 private homes since 2003. And I lived in Toronto for about 16 years, where I co-founded a successful retail business that operates to this day. So I have some business background. I know what it's like to run a small business from year to year. Our goals today include energy efficiency overview and trends, upgrade benefits, costs, and incentives, and mapping the path to an effective business retrofit. Starting with energy efficiency, looking at the big picture here, the average building wastes 30% of its energy. The efficiency adds up to dollar savings, less waste, and less carbon produced. Here in Canada, our efficiency is rising at about 2.5% per year, but our energy use in carbon is still rising about 2% per year because of growth and so on. We need to reduce our combustion to reduce this carbon use. In other words, we need to stop burning things. Let's look at carbon pricing. So Canada has now introduced $20 per ton in 2019. Continues up until the 1st of April when it's rising to $30. It's going to go up $10 per ton per year until 2022 when it reaches $50 per ton. And that's going to have an impact on the way that we use energy here in Canada. Ontario electricity only uses 1/10 the carbon of gas. There's electricity, the very small peak there, and the taller bar here next to it is natural gas. The other ones are oil and propane, and coal would be somewhere off to the left. So as a result of this, your electricity rate would only rise about 1%, but gas is going up 34% by 2022. Efficiency is going to lower your carbon fees, especially if you fuel switch to electricity as a result of this. Looking at the big picture in the changing world of net zero, net zero means consumption equals generation on site. Net zero carbon is similar, but it means that you will probably have to buy some carbon offsets to account for the remaining carbon that you can't get rid of with your on-site generation, etc. The federal government is currently aiming at 30% below 2005 levels by 2030. That's what the logo at the right is all about. The federal government and the City of Ottawa are aiming at net zero carbon by 2050. That's for everyone, including your business. The City of Copenhagen is hoping to reach the same target by 2025, but they started a lot earlier than us. So we have some catching up to do. So looking at net zero and net zero benefits. Now, this chart here, if you look at it, the red bars on the left are before upgrades and the green are afterwards. So you can see there's some quite substantial drops in energy use from heating, from hot water, and from air conditioning especially, but also in general energy use. So this would be a typical view of a net zero project before and after. So what we're doing here is we're lowering our energy consumption by 60 to 100%. So there's dollar savings there. We have electricity generation to offset consumption. So there's dollar savings from that. That's your photovoltaic cells on the roof. You have your lower peak electricity use, which amounts to dollar savings for those who are paying peak rates. Carbon reductions of up to 95%. That obviously translates into dollar savings because we're paying for carbon now. Less waste, higher efficiency, better dollar returns. Moving on to more net zero energy benefits. So when we have no combustion, we have safer businesses. We have lower insurance. This is something that you can take advantage of. You have better workplace comfort. Employee satisfaction goes up. And you have marketing advantages, such as those that are being taken advantage of by some businesses like IKEA or Mountain Equipment Co-op. Here's a net zero example. It's a retrofit that was done on a 1980s row house. However, you could expect comparable results with many small businesses. So the upgrades that were done include a mid-efficiency gas furnace was upgraded to an air source heat pump and electric furnace. The standard gas water heater was upgraded to a heat pump water heater with drain water heat recovery. Air leakage was reduced by quite a lot, down to 1.5 air changes per hour. Lighting and appliance upgrades were applied. All windows were replaced with triple pane fiberglass. And 500 square feet of solar panels were installed to match the reduced usage. So the chart at the top here shows net zero ready. That's before the solar panels were installed. So we're looking at a big reduction in energy use, 63% less, and already a 94% reduction in carbon. And the costs have gone down by about 30%. Now, when we install the solar panels, what happens? Now we're looking at our energy use has gone down to zero. That's the net zero that we've been talking about. Our CO2 has gone down by 1% more. And look at our costs. They've gone down to only 15% of the original. The reason you're paying anything at all is because you have to pay to keep the account open. That's merely your fixed costs, because all the rest of the electricity is being accounted for by the production of your solar panels in the net metering situation. Note that this particular scenario, does not include so-called deep retrofits. The building was not clad with insulation or anything like that. And it has a payback period of less than 10 years. So the economics are there to support going towards net zero. Now, how are we going to get towards net zero? We'll try to give you some ideas of where to start. First of all, you're going to lower your heating and cooling demand so that you can get away with smaller equipment and lower energy use. Less combustion of fossil fuels. and a clean local electricity supply. We'll look at some ways of getting there. First of all, the price of deep retrofits. I'm a little bit skeptical about the approach towards using deep retrofits to get to net zero. The reason is that they are costly and there are diminishing returns. So first of all, looking at a 20% reduction for a modest investment, we're spending $5,000 to get our 20% reduction on our heating bill of $5,000. So we're getting $1,000 a year back for $5,000, which is pretty good. That's in scenario A. That's the pair of bars at the left. The middle set is for a 40% reduction. However, our upgrade costs have gone up quite a bit. We're doing extensive insulation and air sealing, and we're going to upgrade our ventilation systems. So now we're looking at roughly a 10-year payback. Our costs are now up to $25,000, and we're getting about $2,000 a year back. In the third scenario, we're getting a 60% reduction, but our investment is very high. It's going to cost us $100,000, and that's typically what these kinds of retrofits cost these days. So for that, you're going to get full exterior insulation and air barrier. The full foundation is going to be insulated to a high level, and all windows and doors are going to be upgraded. But you're still only going to get 60% reduction of your utility bills. So you're spending $100,000 to get $3,000 a year. The economics don't look so good for deep retrofits. What I would like to encourage instead, as a starting approach anyway, is to have less combustion, to aim for less combustion right off the bat. So in this table, we're actually comparing the energy use and the carbon production for various upgrades. So first of all, the first scenario is we took our old furnace and we put in a more efficient furnace, and as a result, we reduced our usage by about 20% from 100%. So we're down to 80% for that kind of upgrade. And the incremental cost is fairly small. However, if we had instead decided to take out our old AC and put in an operational air source heat pump, we would get much deeper gains. So we're cutting our energy use by 45%, and we've got a 60% drop in our CO2 for taking that route. Bear in mind that we're still keeping the original furnace in this case. It's still there as a gas backup. And in the third scenario here, we remove the gas entirely and we replace it with a heat pump with electric backup. And that gets you 65% reduction in energy and a 95% reduction in your CO2. So these are much more economical upgrades and much more feasible than doing the envelope upgrades, which take a lot of planning, a lot of time, a lot of materials, and they take time to install as well. Going towards looking at our clean electricity grid. So our current electricity grid here in Ontario is pretty clean. We have actually a pretty low emissions factor now because we've gotten off coal here in Ontario. So here's a breakdown of the Ontario grid. 60% of it is nuclear energy. We've got about 25% of it that's coming from hydro, real hydropower. And the remaining part is made up with about 7% wind. And then the rest of it is taken up with gas and solar. We don't have a lot of combustion involved in our grid, so it's pretty clean. The question is, can our grid handle the extra load? If we're going to shift everything off of producing heat directly with natural gas and start producing it with electricity, are we going to be able to handle that? Probably yes, I would say, provided that we also upgrade insulation and air leakage in our buildings. We adopt heat pump technology, and we install photovoltaics on a widespread scale on rooftops. There's a lot of flat roofs out there that have nothing on them but HVAC equipment. Here's an upgrade awareness activity. What do you think would be the most effective retrofit projects when you consider energy savings, cost savings, and carbon savings? Which of those would deliver the highest percentage? And so the 5 scenarios are lighting, upgrading all lighting in an office tower to LED, installing a heat pump instead of an air conditioner in a business. Mind you, we're talking about percentages rather than absolute values here, so the size of the business isn't as important. Installing R60 insulation in an attic that previously only had R30 insulation. Upgrading an uninsulated basement to R10, or installing triple pane windows. So if we look at this scenario, at these different scenarios, the best one for energy savings turns out to be the heat pump, with the worst one being the attic. The attic, the reason being that the attic is the best insulated part of the building, typically. For example, when you have a thin coat, let's say you're outside, you're walking around, you have a thin coat and a warm hat on, you don't put on a warmer hat to be more comfortable. So the lesson there is that it has very little effect insulating the best insulated part of the house. On costs, probably the best cost savings here is lighting in terms of percentages. That's because the electricity is expensive. It costs about 4 times the amount per gigajoule that natural gas does. But it could also be the basement, because basement insulation also has a big impact, especially if you're going from uninsulated to R10. That could be a 20% savings right there. Now, if we look at carbon, the best is, again, the air source heat pump. And the worst is lighting. And the reason being that inefficient lighting produces lots of heat. When you replace it with efficient lighting, you now have to turn up your heating equipment to make up for the difference. And if your heating equipment is fired with natural gas, then your carbon is going to go up. Making it happen. So first of all, you would want to find out where you are and use benchmarking. It's more than just dollars. This is bookkeeping that allows you to make decisions based on the whole consumption picture. It's do it yourself, or help is available through Energy Star Portfolio Manager, which is a free online tool. You can also join Carbon 613. We would certainly help you establish your baseline and targets, or you can have an energy audit. If you're going to have an energy audit, you'll need to find an evaluator. For an office, retail, restaurant, or workshop situation, you would look for an energy auditor or an energy manager. Typically, they would be coming from a consulting engineer or a utility company or something, a place like that that specializes in that kind of activity. For rental properties, then you could use a registered energy advisor if the building was reasonably small. It would need to be Part 9 building code, which means less than 600 meters squared footprint and less than, 3 stories or less. If you rent, lease, or share your building, you can influence your workplace. You can have a green team. You can reduce your energy use through behavior. You can do some small upgrades that have big impact. And you can still join Carbon 613 for ongoing support. You can also work through your landlord. They may be interested in reducing energy use by various means. You can leverage those to get them to move on doing these energy upgrades. You can also discuss rentals with them during your lease negotiations and tell them about these workshops. The more they know about it, the more they might be interested in proceeding down that path as well. Making a plan. So upgrade strategies for net zero. So you always have to consider these various aspects: carbon reductions, the cost of upgrades, yearly savings, cost effectiveness, your goals and targets, and you may need expert help because you may not have access to that information, and you will need to have someone analyze that information for you or provide it to you. Let's look at stepped retrofits for net zero. So these stepped plans start with the most cost-effective upgrades and use savings to pay for other upgrades. And typically, it's building envelope upgrades first. This is a particular scenario that was performed on a building downtown, in downtown Ottawa, that it's a heritage building. So the upgrade scenarios are somewhat limited by what you can do to the exterior of the building. However, when you compare the stepped retrofit scenario to other plans, this results in smaller energy savings, smaller carbon reductions, and smaller dollar savings. So I don't recommend it. What I would recommend instead are more effective strategies for net zero, including this high impact greenhouse gas upgrade scenario. And with that scenario, we cut to the chase. We start with upgrades that have immediate significant impact on energy use, like air source heat pumps and solar photovoltaic cells. Compared with the STEP plan over a period of 5 years, this example had 56% less energy use, which amounted to 740 gigajoules, 60% less carbon production, 33 tons, and 38% lower utility costs, which amounted to almost 10 grand in extra cash. So obviously it's a better route, especially when you consider that both of these upgrades cost exactly the same amount. The capital costs were the same. And you can kind of see, if you look at the two charts, why that is the case. The step scenario has a kind of a belly that sticks up. And the amount of savings are represented by the amount of area that's underneath the curve. So the smaller area there is there, the greater your savings are going to be. And that's the case for every one of these curves with this kind of scenario. So high impact strategies. First of all, they require energy analysis. So you need to get an energy advisory in earlier to get the projected sizing of equipment and the solar photovoltaic cells. You have to arrange financing to support the upgrades because you're going to have more upfront costs. Upgrade the existing AC equipment with heat pumps. That's what I would recommend starting with. Keep the existing heating as backup for now. You don't need to replace your furnace or your boiler yet. Install your solar panels. Then perform your viable envelope upgrades in the most cost-effective order. Deep envelope upgrades may not be necessary to hit the target. If you look at the chart on the right, we reached 90% reduction of carbon and energy use. And upgrade your ventilation systems with heat recovery. What happens when you're tightening up these buildings is they become more airtight, so it becomes more crucial to provide effective ventilation. Finally, when you've done all the other upgrades and your combustion equipment is reaching the end of its life, retire your combustion equipment and replace it with something that produces heat through electricity. So a little bit more about incentives here. Incentives cut your costs. We have the Hydro Ottawa IESO, the Save on Energy retrofit program, which offers substantial incentives for electrical savings and also certified energy manager training. We have Enbridge that offers smart savings, which is similar. And they also have some home efficiency rebates that we'll talk about. So first of all, the Save on Energy program. Don't start your upgrades until you submit the application. They won't accept it if you're kind of in midstream. You need to get in there before you start doing anything. There's a prescriptive track for lighting upgrades, etc. So you get an incentive in dollars per unit of product, but you require an application and documentation. There's also a custom track for everything else that can't be done under a prescriptive track. So there you get paid an incentive per unit of demand or consumption, depending on your situation. And that custom track will cover up to 50% of your project costs, which is potentially a very hefty rebate. The application includes your info to estimate energy savings. It can also be submitted by a third party like EnviroCenter. We have Save on Energy training and support, which is offered by the IESO. So with this program, you need to apply in advance for incentives of up to 50% of course fees. And these will cover the dollars to cents energy management workshops, building operators certification, certified energy manager training. And also note that Enbridge offers similar support for this training. Now, looking at Enbridge's rebates. Bear in mind here that we're talking about all the rebates that are available in Ontario at the present. Obviously, the situation is always changing, but right now, we're pretty much going to cover all the bases as far as we know, as far as I know, about what's available commonly to businesses here in Ontario. So we have the Smart Savings Business Solutions for natural gas customers only. The same rule, don't start your upgrades before you contact them. They have incentives that will cover up to 50% of project costs. There is a fixed incentive program. That is the prescriptive approach. And the performance approach is the commercial custom retrofit program, which is based on dollars per unit of gas consumption. Very similar scenarios here to the IESO programs. But be aware that most investments under this program will only have small impacts on carbon production and may commit you to using natural gas for an extended period. In other words, you're going to buy equipment that may last you for another 20 years. You're not going to sell it in 5 years' time. So it's so-called what we call lock-in. So beware of getting committed to technology that may become obsolete before long. Enbridge Smart Savings Home Rebates. Again, natural gas only. Don't start your upgrades until you contact Enbridge or a qualified service organization like EnviroCenter. There is the Home Efficiency Rebate for residential properties. That would be non-MERB gas users. So it requires an energy assessment through the SO, the service organization, and rebates are applied on assessment costs and for particular verified upgrades. It is a prescriptive program. The home winterization program, on the other hand, is performance-based. It's also for residential properties, but there needs to be a qualified tenant. In this case, it is the person who lives in the building who makes the application, but obviously the landlord needs to also be on side. So if you are a landlord, this is something that you could look at using to get upgrades done in some of your buildings. The tenants must qualify on income. The energy assessments are performed at no cost. And under this program, some kinds of upgrade are done. The most cost-effective ones are done, which are attics, foundations, and walls, can be upgraded at no cost, but only if the energy advisor finds them to be cost-effective. Other incentives. There is some financial support for industry through the NRCan's support for the ISO 50001 standard, where they will offer assistance of up to 50% of eligible project costs. There's also a federal tax provision for clean energy equipment, which would allow you to fully expense your solar energy system and heat recovery equipment and apply a capital cost allowance of 100%. So you could talk to your accountant about this if you're planning to go in that direction. Small business incentives elsewhere. Well, in Nova Scotia, they brag that they have a small business rebate, and the average amount that's given out is just over $5,000. And they've had more than 500 small business participants. In the Yukon, the government of Yukon is offering the Good Energy Program, which gives 25% rebate for businesses on approved project costs, 40% for nonprofits or NGOs. I guess the question is, why don't we have any rebates from Efficiency Ontario? Maybe something to talk to your MPP about. So, if you're proceeding down this path, talk with the experts. And the closer they are to a vested interest in the outcome, the better. EnviroCenter, our program, Carbon 613, Envari, Hydro Ottawa, Enbridge, City Electric Supply is one company here in town, and other similar companies that facilitate these kinds of rebates. So for green retrofit success, first of all, I advocate that you start the process with an open mind. The best upgrades are not always obvious. Get energy modeling, because it takes in all the effects of each energy use and it's your best guide to upgrade impacts, because within that energy modeling, they can actually model those upgrades. Ventilation and comfort need to be carefully considered, and so you would want to go to an expert in that field. Decide on the type of heating system that best fits the energy picture. Don't commit to a system that's going to be obsolete or oversized. Consider the energy balance. For net zero, all energy use needs to be offset by recovery or generation. So you have your HVAC, you have refrigeration, office equipment, motors, lighting, versus what heating or cooling energy can be recaptured or reused, and how much electricity can you generate on your property. You need to get that balance right to reach net zero. For a green retrofit, order matters. Target the biggest carbon reductions first. Start by replacing your older central AC with heat pumps. The incremental cost is small and operating costs will be similar. Solar PV next, then do the cost-effective upgrades. So now we're going to talk about some of the upgrades. Some of this we've covered in part 1, so I'm just going to breeze through it here. The easy energy efficiency upgrades would include things that would reduce your heating bill by about 10%, such as poorly insulated attics, uncontrolled air leakage, idling or redundant equipment, exhaust fans with no heat recovery, older equipment that produces heat or cold. Deeper energy efficiency upgrades. This includes poorly insulated walls. If there are empty wall cavities, typically they're not opened up like the one in the picture here. They can drill small holes and implement a speedy, inexpensive upgrade that can save up to 20% on your heating bill. The cellulose is packed into the walls, and it also reduces your air leakage, so you get a lot of bang for your buck. You can also apply exterior board insulation under new cladding. Let's say you were intending to put in new cladding. This would be a good approach to take. You could also save up to 20% depending on the situation if you're starting with uninsulated walls. But it's obviously more expensive, or maybe not obviously, but it is more expensive to put this board insulation. It can be economical if you're upgrading the siding or facing anyway. Then it becomes more of an incremental cost. Installing an air barrier here also helps reduce your air leakage. So that can be a good approach. On the foundation, we have savings of up to 20% for interior or exterior insulation, which can be cost effective, but it requires expert advice. The reason being, any water leakage must be resolved first. In fact, water is usually the prime concern here in some way. If you have a poured concrete foundation, it's very stable and you can insulate it from the inside, usually without too much concern if there are no water issues. If you have concrete block, it's also usually okay. But if you have stone or rubble, you have to proceed with caution. The exterior insulation is best. So get expert advice for foundations. For windows, it's not usually cost effective for energy to install windows. You get less than 10% savings, but you get increased property values. They also help control sound and comfort. If you're going to install them, install the best you can afford, which would be fiberglass triple pane with long warranty. By the way, triple pane are becoming just run-of-the-mill windows these days. You can also install awnings, blinds, or even storm windows that offer effective comfort improvements. Window treatments, that is, window films and so on, can be applied to glass to help address summer overheating. So there's a lot of ways you can upgrade windows to improve your energy situation. Solar energy. You have big capital costs but high returns. You will need to get a site assessment, but your roof could be suitable for photovoltaics. That's where you're producing electricity. You have long-lived equipment with very little maintenance. Net metering can offset your entire electricity usage each year, depending on the sizing of your equipment and your loads. They are a necessary component of net zero. Obviously, you've got to have generation to offset your use, unless your use happens to be zero to begin with. The install costs are typically about $3 per watt. So for a 2,000 square foot array, it would cost you about $15,000. There's also solar thermal. About 15 years ago, these were strongly advocated for water heating, but that has ended up being perhaps not the best approach for Canadian climate. They're still useful for some commercial situations. For example, water heating in summer, or air preheating for winter ventilation. This product, Solar Wall, has been used in a lot of warehouse and barn type situations to help preheat the air before bringing it into the building. HVAC, all heating and cooling. Make sure your equipment is working properly. If it isn't working properly, be careful about upgrading it without considering your energy plan. At this point, I would strongly encourage nursing your older equipment along rather than upgrading it to the same kind of equipment. On the issue of heat distribution, evaluate what you've got and add zone controls if necessary. If you, with your thermostat or your building automation system, you should set occupied settings of about 20 degrees during winter or 25 in the summer for good energy efficiency. When it's unoccupied, set them back. On the weekends, you can set them back to 17°C in the winter or 20, or you set them forward to 28°C in the summer. More energy savings. If you've got a boiler system, here's a boiler system for an older building. It's about 200,000 BTU. If you have a small hydronic system, and I've kind of suggest that this is in that category, you can add mini split air source heat pumps to supplement and eventually replace your boiler system. With multiple indoor heads, mini splits can provide better comfort control. If you have a large hydronic system, you can service it for best performance. You can perform energy upgrades to existing equipment, which would result in 10 to 30% savings, but don't upgrade without consulting your long-term energy plan. You want to avoid lock-in. For furnaces, this is a rooftop unit here. When your equipment approaches the end of life, you can upgrade to heat pumps on your roof. This is actually an Amana heat pump system that's meant as a rooftop unit. So they are available. If you have a standard furnace, you can replace your central air conditioning unit with a heat pump sized to about 2/3 of the heating load and eventually upgrade to an electric furnace. When you do upgrade to your electric furnace, you can close the gas account and capture those fixed costs as savings. Heat pump replacement will typically reduce your energy use by about 40% and your carbon use by about 60% while maintaining or lowering your operating costs. So it's a pretty good investment. On the domestic hot water front, what we see in the picture here is a point of use water heater. If you have an office that does not have showers, I would advocate using these because they will reduce the amount of water use, because you only have to run the water for a second before you get your hot water, rather than taking it from a central water heater where you're going to have to run the water for a while before you get it. You might be running it for minutes. If you do happen to have showers, then you would want to think about installing heat pump water heaters. They are available now in commercial sizes. They take energy from the indoor air and they use that to heat the water. They can also reduce your cooling loads in summer because they're actually going to be cooling the air inside. They can be located to take advantage of local hot zones such as kitchens. And they will reduce your water heating energy by 40%. You can also add drain water heat recovery units for about a 15% reduction. Looking at ventilation now. All your fan motors should be ECM, energy efficient motors. Adding heat recovery to your exhaust will recapture about 50 to 75% of the heat. Let's talk about these fresh air machines. Some people call them fresh air machines because that's what they're doing. And HRV and ERV seem to be terms that not everyone understands. HRVs are, as compared to ERVs, more efficient. They're good for exhausting high humidity zones like showers, places where there are showers, etc., or maybe a lot of boiling water, a lot of steam. They're better at reducing winter humidity. So if that's what you want to do, that's maybe the direction you should go. If you have an ERV, it's better at maintaining the humidity levels. It's better if you're in an air conditioning situation. You're not going to be bringing a lot of humid air in. It's going to reduce some of the humidity. And there's no drain required from a technical perspective. An HRV has to have a drain to drain off that condensed water. ERVs generally do not need a drain. And that the unit in the picture is a commercial unit, a commercial HRV unit. You can also have both. You can buy an extra core for your HRV and you can switch it out from winter to summer so that you can have the best of both worlds. By the way, you can keep your washroom exhaust fans in these situations, or you can replace them depending on what you want to do with your system. It's more efficient, generally in a commercial situation, to replace the washroom exhaust fans with an HRV that's running continually, or an ERV. Air conditioning. If you have mini split AC, make sure that the unit, if that's what you're adding, because a lot of restaurants and so on are buying these mini splits, make sure that the unit is also a heat pump and get it slightly oversized. Size the unit to about 2/3 of your heating load. Multiple indoor heads will ensure good local climate control. If you have central AC, replace the unit with a multi-stage heat pump sized to, again, 2/3 of the heating load. With conservation and upgrades, these units can eventually supply all your heating and cooling. Just looking at some of the other aspects of smaller businesses, often you have refrigeration. So the top upgrades are to replace your open vertical display, and that's what that is in the picture, with a reach-in with glass or acrylic doors. Reduce or eliminate anti-sweat controls, night covers for open horizontal cases, upgrades to high-efficiency compressors. If you have walk-ins, you can put in an automatic door closer, door caskets, or strip curtains. New evaporator efficiency controllers. You can put in LED lighting and have ECM motors for your evaporator fans. Now, a lot of these things are actually eligible for rebates as well under the IESO program. Lighting. In the lighting world, LEDs are the answer. Low energy use, good quality light, long life, incentives. But keep in mind that it's typically less than 10% of the building's energy use, so there are small energy savings, and you have small or negative carbon savings for this and other interior electric upgrades because you're shifting the heating load onto your gas systems, perhaps. What energy can you recapture and reuse? You can recover heat from anything that flows out of the building. And in this case, that's the drain water heat recovery unit. You can use, obviously, HRVs or ERVs that we've already discussed, the drain water heat recovery. You can also, if you have clothes dryers, you can capture energy from the clothes dryer exhaust. Now we have heat pump clothes dryers that will recover all the heat from your exhaust. You don't have to vent them outside. So you can use clothes dryers to heat your house. You also have the heat pump water heater. So those are packaged systems that have the energy recapture built into them. But what processes do you have in your business that produce unwanted heat? Think about how you might be able to transfer that unwanted heat to areas where heat is needed. So here's some examples of energy collaboration. There's district heating and cooling. We have here in Ottawa, we have some quite sizable district heating systems. There's the Cliff Street plant that serves Parliament Hill and a host of other properties all along the Ottawa River, essentially. The advantage of these is not that they are inherently efficient, but that the shared central system can be configured for maximum efficiency. And they actually are in the process of upgrading the system here in Ottawa. You also have interseasonal heat transfer. This is something that has now been going for quite a while. And here's a picture of a system that it was installed in Okotoks, Alberta. And what they do is they can store the heat in the ground and then extract it. So what they do is in the summer, you're going to store the heat deep underground, and in the winter, you're going to take that heat back out. So it's stored for very long periods of time, and they are incredibly efficient. I don't know if you can see the number there for the COP, but it says 30. So they are not 300% efficient. They are 3,000% efficient. You get a lot of energy out of them compared to the amount of energy you put into them. So they're incredibly efficient. We also have shared building heating. So some overheated buildings share with underheated buildings. For example, the bakery next door. Maybe you've got a bakery next door. See what they're doing with their excess heat and see if maybe you can get some of that. By the way, this Drake Landing solar community has been running for over 12 years now. So it's quite a successful project. So how much electricity can you generate? If you've got a rooftop, the south sloping is best, but east and west combo could also be okay. Flat roofs are great. The optimal angles are possible on flat roofs. This is actually a picture of a commercial installation here in Ottawa on a flat roof. There's snow and dirt to be cleaned off. If they're roof mounted, they're a bit harder to clean. So that's one of the disadvantages of the rooftop units. If they're ground mount, they are more expensive due to piling and other requirements, but they produce more electricity and they're easier to maintain because of snow. You can get the snow and dirt off them more easily. And their system capacity is not limited by your roof size. So there are advantages to going that route. You have to think about whether there's any area on your property that might be suitable for solar panels. When you've decided what you're going to do, you're going to need to find the right contractors. There's some advice from the CHBA. You have to know what you want, have a realistic budget, plan for the long term, protect yourself with a written agreement, don't compromise on quality, don't choose contractors on price alone, and beware of direct sales. Clear instructions and ongoing inspections are necessary with some contractors. Consider changes of plan based on contractor advice because they often know what they're talking about. But first, verify with your energy manager. Consider hiring a concierge service to oversee upgrades. So you have someone there with some expertise and they oversee the project to make sure everything's being done according to spec. Get a permit if you need one. You may have expertise in-house at your business, but don't overextend yourself. Plumbing, electrical, and gas work all require licensed contractors, and there are health and safety concerns in some situations. Now to look at some of the green tools and certifications. We have, in terms of energy tools, Natural Resource Canada offers these data analysis software and modeling tools. There's HOT 2000, which is kind of the Canadian standard for residential energy modeling. It is available for free download. There's RetScreen, which is clean energy management software. You can model all kinds of things in there, and we can also look at the financial aspects in that software. And it will accept projects of any size. And it's used internationally as well. There is the heat pump pre-screening tool, which provides rapid assessment of heat pump systems. And these and many other tools are available for free download at the NRCan site. They also have a retrofitting buildings page. I've got a link to it here, and where they talk about minor, major retrofits, deep retrofits, and they have major energy retrofit guidelines laid out. So have a look at that site because there's lots of really useful information there for small businesses. Certifying your building. There is a zero carbon building pilot program, LEED, Passive House, Energy Star, Net Zero Home Labeling. So on the certification front, the CAGBC, the Canadian Green Building Council, they deliver LEED and the zero carbon building standard. Have a look at their website to find out more about that. Passive House Canada, they deliver Passive House and EnerFit, PHI. So these are very low energy use buildings, not necessarily incorporating solar generation. Primarily for new builds, but they can also be commercial or retrofits. Natural Resources Canada and CPEC, they have the Energy Star Portfolio Manager, which allows you to benchmark your energy performance. It's an online free tool. And there's a couple of other areas here, but they're mainly for larger industries or buildings. You can check them out on the NRCan website. This is worth having a look at for smaller buildings, smaller residential buildings at this point. It's the Net Zero Home Labeling Program that's delivered by the CHBA. It's going to be private homes and MURBs. It can also apply to rentals. There have been more than 250 of these labeled so far, including several in Ottawa, and it's delivered through EnviroCenter and other qualified SOs. So talk to us if you want to know more about that program or visit the CHBA website. So enjoy the outcome of your upgrades. You end up with a better building that has better comfort, lower costs, more resilience, it's less affected by weather, and better health. Your air quality should be improved. You have a better business. Your business reputation is enhanced. You have better customer and employee retention, and your operational knowledge and planning are better. And this all adds up to a better city. You are taking action on climate. It adds up to better public health, resilience, green economy, and the dollars stay in town. All of these upgrades are done locally. And here we have a deep retrofit video for you to watch that was done by Efficiency Nova Scotia.
My name is David Pope. I am owner-manager of Jati's Mini Mart and Kenny's Pizza in Airshot, Nova Scotia. We're open 365 days of the year. We're always here for the customers. We spoke with somebody from Efficiency Nova Scotia, and they sent down someone to walk around the property, see different things that we could use in here, make it more energy efficient. First thing we did was the installation. In the wintertime, even though the machines were putting off a lot of heat, all the heat would just rise and leave the store. We also looked into heat pumps, which helped to cool down the store in the summertime, especially with the pizza restaurant inside. The heat was unbearable when you walked in here for customers and employees. We looked into getting a walk-in fridge and freezer. It definitely helped out big time with the heat, the noise, and people know everything cool is in that one area. It's crazy the difference. We've changed it so much in the 3 years that we've owned it. Since all the upgrades have been done, it's not as warm and humid, and people come in, sit down, relax, get out of the sun. The power bill itself is on average around $1,000 lower a month. And all the money that we've been saving has been going into the outside of the building. Dealing with efficiency throughout the whole process was very simple, easy, which is awesome, especially for small businesses that do need the help. I would definitely recommend it.
Carrying on here, I wanted you to have a look at some of the fantastic work that's been done here in Ottawa along these lines. There is Karen's Place, Salis Clementine, which is kind of located near Billings Bridge. It's a certified passive house building. It was completed in 2017. It's 42 bachelor units, 22,400 square feet. The heating costs are only $1,134 annually. Yes, you heard that correctly. For a building of this size, that is nothing short of remarkable. It is LEED Canada Platinum rated, and they kept track of the upgrade cost premiums, and they only amounted to about 10%. So the incremental cost was only 10%. It only cost 10% more to build this building that uses probably about a tenth of what a normal building that size would use. Here's the Mosaic Center in Edmonton. It's a net zero energy commercial building. So this and the previous building were built from scratch. It was completed in 2015. It has a ground source heat pump system, or a geo-exchange system, which is 32 boreholes going down 70 meters. That's located under the parking lot. And it's also rated LEED Platinum. It has 213 kilowatts of solar panels up there on the roof. And here's one that we also have a video of that we'll show you at the end, but it's the Wilkinson Avenue warehouse in Dartmouth, Nova Scotia. And I include this because it actually represents a scenario that could be applied in a retrofit situation to warehouses, for example. It's a 65,000 square foot warehouse, and which they insulated with R20 walls and an R40 roof. They also were able to upgrade the slab, which might not be as feasible for an existing structure, but they only use 6 air-to-water heat pumps for radiant heating of this building. It does have backup condensing gas boilers, but it is a zero-carbon warehouse nevertheless. They have a net-metered solar PV system on the roof as well. And I have a video here for you to watch.
Under the Paris Agreement, Canada committed to lowering emissions by 30% below 2005 levels by 2030. With 17% of emissions generated from the built environment, creating low-carbon buildings is of critical importance to meeting these international targets. The Canada Green Building Council created the Zero Carbon Building Standard as an actionable made-in-Canada solution to achieving Canada's climate change commitments.
355 Wilkinson Avenue in Dartmouth, Nova Scotia, developed by Eastport Properties, is the first industrial building to receive Zero Carbon Building Design certification from the CAGBC. 355 Wilkinson is designed to generate zero carbon emissions in the operations of the building while providing tenants with a low operating cost through a $0 central heating bill. We reduced emissions and energy use by minimizing air infiltration, providing better insulation values, and installing efficient heating systems with automated controls. The result is a sustainable and high-performing warehouse with a tight and well-insulated building envelope, innovative design features like vertical storing loading docks, low operating costs for our tenants, and zero carbon emissions in building operations. We set out to build a new generation of zero-carbon warehouses, and that's exactly what we've done. An added benefit is the ability to offer our tenants the opportunity to have a zero central heating bill, which we think is pretty incredible.
With their commitment to pursuing zero carbon, Eastport Properties is paving the way for a new generation of zero-carbon warehousing, an asset class that represents over 2 billion square feet of real estate across 11 Canadian markets. The Zero Carbon Building Standard provides a path for both new and existing buildings to reach zero carbon. It's the only way we build for our future. For more information about CAGBC's Zero Carbon Building Standard, visit our website.
Thank you to everyone who participated in this presentation. Please contact EnviroCenter for more information, or if you want us to help you with your net zero or energy efficient projects.